Hello everyone, welcome back. We are continuing the very last chapter in our book. We're getting close to the end, and in today's video we want to do a topic that is kind of fun. This is another one I never learned in school. This was something I never got taught all throughout junior high, middle school, high school, college, and then it showed up, and as a teacher I've had to learn how to do it. It's how you make a two-way table. And a two-way table is just a table that you can read kind of two different ways. You're going to compare two different categories of information, and it looks pretty interesting, and it's not as hard as it looks. It looks sometimes pretty intimidating. This is actually one of the skills that if you were in the regular 8th grade math class, this is also something that the regular 8th grade math class is required to learn. But it's in our book as well, and so we'll go over it. So basically I have just a few notes on here in case you just are not familiar, you've never seen one of these before. In this one that I made, this is the actual data, I didn't make this up, from my math class, my regular math classes, and my algebra classes, how many boys I have and how many girls I have in my regular math and then in my my regular math and then my advanced math classes. So I have two categories. I'm comparing my classes and the gender of my students, and those are my categories. I'm actually going to go ahead and erase those. So those are the two categories. And then all the numbers inside the table, the number of how many boys I have in regular math. You can see I have 23 boys in regular math. I have 20 girls in regular math. I have 21 boys in my algebra class. I have 21 girls in my algebra classes. So that one was kind of neat that it was equal. But anyway, those four numbers inside the actual chart are called the joint frequencies. Joint frequencies. And so I drew four little arrows to try to point all four numbers there would be called a joint frequency. Okay, got it. Joint frequency are the numbers inside. So what they're going to do is they're going to ask you, especially at the beginning of our lesson today, they might ask you, okay, how many total students are in Mr. Reed's math classes, his regular math classes, right? How many total students does Mr. Reed have in his algebra classes, right? They might ask you how many boys overall are in these classes, or they might ask you how many girls overall are in these classes. And so what we need to do, if there's only four squares like this, what we're going to need to do is we're going to have to put some totals on here. And this is where it gets kind of fun because you get to do a little bit of organization yourself, and you get to total these things up, right? And then you can also put the total down here. We can get the total down here, right? We could do a total right here, and it's basically a little addition question, right? How many total boys do I have? Well, let's see, 23 plus 21, that is 44. So I have a total of 44 boys in all of my classes this year. And then girls, I can add this up right here and get 41. I had a total of 41 girls in my classes this year. But I can also add going across, can't I? So I can see how many students do I have in regular math? 23 plus 20. That's 43. I can see how many total students did I have in Algebra 1 this year? 21 plus 21. That's 42. Okay, those are called the marginal frequencies right here, right? So when the question asks you to find and interpret or calculate the marginal frequencies, that basically means just total everything up. Oh, and then I almost forgot my favorite part. And this is what's so neat about these. You know how a lot of times you do questions and you're like, well, I think I did it right. I'm not sure. You'll always know if you did these right because look, if I total up these two, what do I get? If I want to find the total number of students that Mr. Reed had this year, I can add these up and get 85. And you better double check it, right? This total needs to be the same as the total going down right here, right? So 85 is the right answer for adding up these two. But if I add up these two, does 44 plus 41 also equal 85? And it does, right? And so you're guaranteed to know if you did it right. If you add these two numbers up and get 85, these two numbers better equal 85 as well. Because if they don't, that's a clue you made a mistake, and then you need to go back and see what you did wrong. But that's a cool thing about these is because you've always got this kind of magic box down here, the total of the totals, right? And this little magic box in this bottom right-hand corner will always be the grand total of everything, and it'll let you know if you did everything else right, because it should match. 43 plus 42, that equals 85. 44 plus 41 also equals 85. That's why I like these so much, because there's no really guessing. You know that you've got it right. Okay, so now I found them, right? all these purple numbers and the green number is a marginal frequency. And then if it asks me to interpret it, right, I'm not going to write all these out. But if I wanted to, I could say there were 43. I could go right here and say there were 43 regular math students. Right, I'm just going to abbreviate to save time. I could say this person had 42 algebra students, right? Algebra 1 students. And so it's really just making a statement, right? I could say there were 44 boys, 44 total boys in my classes this year. I had a total of 41 girls in class this year. And this is what all it means when it says interpret it, just kind of make it into a statement. I could also say 85, right? I had 85 total students across all my classes, boys, girls, doesn't matter. I had 85 total students this year in my 4 math classes, right? And so that is going to be the main gist of this lesson. If you don't learn anything else about the rest of this video and you'll just watch these first 6 minutes, that is the most important part, at least for me, for a two-way table, right? Can you take the numbers, total them up, get the grand total, and then interpret it, be able to take those numbers and write, brief little statements that you could use to describe the data that was given to you. And that's the quick 5-minute explanation of a two-way table. But our book isn't always that nice. They're going to make us go a little bit more advanced. Here's what they could do to you, right? Here's another one. I just made this one up as well. This isn't real information. They might give you one that's incomplete, right? You see how we've got some numbers here that are missing? This is kind of like a Sudoku puzzle, if you like those. I don't know about you guys. I kind of like them. You've got some numbers filled in, but you don't have them all. And so they might ask you to complete the table and fill in the missing numbers, okay? So if they ask you to fill it in and it's not all in there already, well, now you've got to use your brain a little bit, right? Whoops, I didn't put total. You got your totals over here. You got your total down here. But you've got some stuff missing, don't you? I can't add up these because I don't know the number. I can't add up these. I don't know the number. I know my grand total right here, the biggest magic number at the bottom right, is going to be 150. But I can't fill in some of these other numbers, can't I? Right? If I know the grand total is 150 and I've got 98 up here, can I do 150 minus 98 and get this number right there? I should be able to, right? I should be able to get 52. So I know this has to be 52 because that would make sense. 98 plus 52 is 150. And now that I know this total, can I say, hey, 52, this is how many people have a computer and how many people have a phone. If 52 people said, yes, I have a computer, and there was a total of 98, I should be able to get this number, shouldn't I? 52 plus something has to equal 98. So I could do 98 minus 52. So this is just basic subtraction, right? If I can do it correctly, 46. And now we're starting to get all sorts of numbers rolled in, can't we? Now that I have 46, can I add up 46 and 11 right here? I could, right? 57. Let's see. There's a couple ways I could get this number. I know something plus 11 has to equal 52, so I could do 52 minus 11 and get 41. So I know this has to be 41. And now there's 2 ways I could get this last box that I don't have. I could just add up 52 plus 41 and get 93, or I could have done 150 minus 57. That would have been the same thing. So it's kind of like a Sudoku brain teaser. You just got to use mathematical reasoning. If you want to do a quick double check, sometimes if this was me, I would want to double check this just to make sure, because since we kind of went all sorts of random orders, there's a possibility my numbers don't match up. Let me just do a double check. Does 52 plus 41 equal 93? Yes. Does 46 plus 11 plus equal 57? Yes. Does 93 plus 57 equal 150? Yes. And then going across those two, does that equal 98? Yep. 52, yep. If I add those two together, does that equal 150? Yep. So that looks pretty good. So I could interpret this, right? What do all these numbers mean? What was the whole point of that? Right? I could say 52 people. I'm going to abbreviate. This is the most annoying thing ever to put PPL, but I'm in a hurry. I don't want to make this video too long. I could say 52 people have a phone and a computer. right? 52 people have a phone and a computer at their house. I was thinking of like people trying to do online assignments like this. I could say 46 people have a computer. They say yes, they have a computer, but they don't have a phone. So I could say 46 have, I'm going to do C, have a computer, but no phone. All they have is a computer at their house. You could say right here, 41 people don't have a computer, but they have a phone, right? 41 have a phone, but no computer. COMP is my abbreviation for computer. Whoa, I'm completely off my board there. Sorry, guys. I wasn't paying attention. And then I could say 11 people, these 11 people, they have a phone, no computer. 11 people don't have anything. They don't have a phone or a computer at their house. They don't have a phone or a computer. Right? We could also put some other numbers in there. We could say this total right here, this 93 means 93 people have a phone, right? 57 people do not have a phone. We could say 98 people have a computer at their house. 52 people do not have a computer at their house. We could also say 150 people were surveyed, right? There's all sorts of statements we can make. And so if it asks you to make any statements, you've got a whole bunch that you could do, right? I just put 5, and there were still some more that I could have put on my board. So if it makes you fill out your own table, don't have a panic attack. Just use common sense. Find the numbers that you can fill in. Use some subtraction like I had up here before I erased it, and you'll be good to go. Okay, we are almost there. I think I have just 2 more boards left. Actually, kind of 1.5. All right. This one is the maybe most confusing one, but it's really not even that bad. Let me move my board back in the screen here. Instead of just being marginal frequencies and joint frequencies, now look what they're going to have in there. They're going to call this, hey guys, calculate the joint relative frequency. That word relative wasn't in there earlier. And the marginal relative frequency. So let me show you what this means, because this is different than the first board we did, my one about the boys and girls in my classes. These were just called marginal frequencies, right? Marginal frequency, and these numbers were the joint frequencies, those black numbers. Here, now it's not just marginal, it's marginal relative and joint relative. That word relative is in there, and we didn't have that before. It's not that hard. Let me talk to you about what it means. What this means is it's going to want our answers as a percent, right? It's going to want our answers as a percentage or a decimal. So whenever you see that word relative, that's your clue to make your answers as a percentage or as a decimal. And we're going to do that actually down here in this chart. Before we can do it as a decimal or as a percentage, we just need to figure out the regular numbers, right? So if I go over here, this is going to be my original two-way table. And I'm going to fill this out just like we did the first one. I'm not going to try to do everything all at once. I just want to make it nice and easy and simple. We're going to do this just like normal. So you can see what we've done here. We've surveyed some students in different grades, 7th grade and 8th grade. We've named off some different brands, popular brands, Nike, Adidas, Under Armour, and we just asked them which to vote for one of those, right? 7th graders vote for Nike, Adidas, Under Armour. Same thing with 8th graders. And so I can just total these up. It's probably going to be easiest to go across here. 52 plus 46, it looks like 98 students voted for Nike total. It looks like we have 81 students who voted for Adidas. 45 plus 55, it looks like 100 students voted for Under Armour. Now if I add these three together, oh boy, you're going to put me to the challenge here. That's 0, because that's a 10. Carry the 1. I think that's 140. And then add these three up right here. That would be 9. 5, boy, is that 139? Now, I just added that in my head, and you can see that I wasn't the most confident. Let me do a quick double check. Let's do the total of the total here, this super important number. Sometimes I like to put it in a different color just to make it stand out, because it's kind of the big, bad number at the end. 140 plus 139 is 279. If I add that up over here, that would be 9. 7.1. Yeah, I got 279 both ways. And I'm not trying to hate on anyone who needs to use a calculator. If you wanted to use a calculator for all those, totally do it. Great idea. Use your phone calculator. I don't really care, right? And so basically, these numbers are the, right? These are the marginal frequencies. These are the marginal frequencies, right? These numbers down here, these totals that we added up. And the joint frequencies are the red numbers up here. So that is what we did normally, but now this question wants us to do the joint relative frequencies and the marginal relative frequencies. So what we want to do is put all these as a decimal out of our magic number down here at the bottom, our 279, right? So we know that we talked to 279 total students, right? That's our total. There were 279 students surveyed. I got it from right there. And so we're just going to take all these numbers, all these red numbers, and I can even do the orange ones, I guess, if I wanted to, and I'm going to divide those by 279 to find out what percent of our students were 7th graders who like Nike. What percent of our students were 7th graders who like Adidas, right? And so I just take each number in our chart and divide it by 279. Simple. So, for example, for Nike, what am I going to do to get this number? I'm going to take my Nike number 52. I'm going to do 52 out of 279, right? And I'm going to divide it. I'm going to use a calculator. You could write it as a decimal. You can write it as a percent. Obviously, I'm going to round this. I'm going to put 0.186. Or you could put 18.6%, right? But I'm just going to do decimal. It's going to take more space to make a percent sign. For Adidas, I'm going to do 43 divided by 279, right? Adidas is going to be 43 out of 279. So 43.154. So 15.4% of our kids were 7th graders who liked Adidas. For Under Armour, I'm going to switch that 43 and make it a 45. I'm going to do 45 divided by 279. And we'll see that we get 16.1% or 0.161 of our students were 7th graders who liked Under Armour the most. I could add all those up and get my total right here, but I could also just do 140 divided by 279, right? I could see, okay, how many 7th graders, what percent of our students were 7th graders? 140 divided by 279. Looks like 50 I'm going to round that up to 50.2, 0.502. Right? You can see that 50.2% of our students were 7th graders. And then I can do the same thing with 8th grade numbers over here. 8th graders who picked Nike was 46. I can do 46 divided by 279. And you see this is where a calculator, 0.16, I'm going to bump that up to 5. 0.165 or 16.5%. Adidas would be 38 divided by 279. You see the 38 right there. And whoops, don't have the 9 on my calculator yet. 0.136. So 13.6% of our students were 8th graders who picked Adidas. And then for Under Armour, that's 55. So I'm going to do 55 divided by 279. And so I'll make sure the assignment has the calculator set up on it, 19.7%, or I'm just going to put 0.197. And then I could add those three up and get my total, but it would probably going to be easier just to do 139 divided by 279. Find out what percentage of our students are 8th graders, and I'm going to do 139. Whoa, that is not a 3. Divided by 279, and get 0.498, 49.8%. And that looks like everything should add up correctly, right? If I want to figure out what the total percentage, pick Nike. We had 98 students who liked Nike out of 279. So what percent of our students enjoyed Nike the most? Okay, 98 divided by 279. This is one way to do it, 0.351. Another way to do it would be to just add those together, right? It should be the same thing, right? If I add up 0.186 plus 0.165, I should get the right answer. See, same thing. So you could do 98 divided by 279, or you could just add those two together. It should be the same thing. 35.1% of our students pick Nike. Right? Same thing for Adidas. I could do 81 divided by 279 and get this. 0.290, 29%. Or I could have just added 154, and 136. It would have been the same thing. And the same thing with Under Armour, 100. I could have just done 100 divided by 279. This is the way I would prefer to do it. It just seems faster to me. 0.358, or you could just add those numbers together. Okay, and just like the other ones, when I add up these three, when I add up those, it needs to equal, in this case, it's not going to equal 279. It should equal 100 for 100%, right? So if I add up these two right here, 50.2 and 0.498, it needs to equal, hang on, I messed that up, 0.502 plus 0.498. See how that equals 1? It should equal 1 for 100%. When I do my percentages over here, it should equal 1, 0.351 plus 0.290. Now, if yours is equal to like 0.99999, don't have a freak out. Sometimes the decimals, see, like, look at that, 0.999. Sometimes just because I rounded them, you're off by maybe 1,000th of a percent or 1,000th, and that's okay. And so there we go. So you can see the difference, right? This, what we did up here, this is called just their marginal frequencies or their relative frequencies. This just uses the actual numbers. When they ask for the joint relative frequency, did I say that right? Let me go back. I don't know if I said that right. The first one that we did, where it has just regular numbers, this is just called marginal frequencies and relative. No. Marginal frequencies and, what's the other word I'm looking for? I can't remember it. Marginal frequencies and joint frequencies, sorry. This is just joint frequencies and marginal frequencies. When it puts the word relative in there, joint relative and marginal relative, now you need to do it as a decimal or as a fraction. I'm sorry, as a percentage or as a decimal. And so here you can see all of the same numbers just out of 1 instead of being out of 279. Now these are all out of 1 because they're all percentages or they're all decimals. So that's when it gets a little more confusing, but it really wasn't that bad, right? We just had to take a calculator and divide everything. Okay, I think I'm going to stop. There was one last thing. I don't think I'm going to put this in an assignment for you guys, but just for your benefit, there is one thing called a conditional relative frequency. And you're like, holy cow, how many things can there be, right? Conditional relative frequency. I don't think I'm going to give you any questions about it, but what that is, do you remember how, like, whenever we made this table, we divided everything by 279, right? The overall total, the total of the total was 279. If they ever ask you for a conditional relative frequency, now you just divide everything by the total of that column, right? So if, let's say, for example, I asked you, instead of asking what percent of the students were 7th graders who like Nike, what percent of the students were 8th graders who like Nike, instead of saying what percent of the overall total, what if I just said what percent of the 7th graders like Nike? Not what, you see the difference, right? Instead of saying what percent of everybody was a 7th grader who liked Nike, what if I just said 52 students pick Nike, what percent of the 7th grade only, and I don't even care about the 8th grade anymore. If I just say what percent of the 7th graders pick Nike, right, and I just completely cover up this row, how would you figure that out, right? If I just said what percent of the 7th graders like Nike, wouldn't you just do, oh my goodness, my board's about to fall down. Wouldn't you just do 52 divided by 140? And if I said what percent of the 7th graders liked Adidas, then you would just do 43 divided by 140. So that's the difference. If it ever says conditional, see up here it said relative. Relative is where you use the grand total, 279. But if I wanted to do conditional, I could do the same thing, right? For 7th graders, I could do, for Nike, I could do 52 divided by 140. And for Adidas, I could do 43 divided by 140. And I'm not going to write all these out, but I might just do the 7th grade ones. For Under Armour, I could do 45 divided by 140. So instead of figuring out the total of, out of everyone, now I'm just doing the 7th grade all by themselves. Just basically cover up those numbers, right? I don't need those numbers. I can say, okay, for the 7th grade, if I just wanted 7th graders only, 52 out of 140 picked Nike, that is 37.1%. And so I could say, okay, 7th graders 37.1% of just the 7th graders, not of everybody, right? And then same thing with Adidas. And so this is called the conditional relative frequency, 30.7. And then the Under Armour is going to be the 45 divided by 140. I don't think you're going to have any questions like that, 32.1. I'm going to try not to give you too many of those, but I could add those up, and that should equal 100, or in this case, 0.999, which is close enough, right? And so a conditional relative frequency is just going to do the 7th grade only compared to the 7th grade, right? And I could do the same thing with the 8th grade. I could just do the 8th graders right here. I don't care about the total anymore. Now I'm just doing 8th grade only. And I could do 46 divided by 139 to get the 8th grade percent who picked Nike. I could do 38 divided by 139 to get the 8th grade percentage who picked Adidas. And I could do the 55 divided by 139 to get the 8th grade who does Under Armour. So that is called conditional relative frequency. If you get a question like that and you're confused, feel free to email me or pause this video, rewind it, do whatever you need to do. I'll help you. So I'm going to stop right there. Thank you so much for watching, guys, and I will catch you guys tomorrow. See ya.